Hey guys, good evening. Andrew here. I want to take a few minutes to talk through stick shift launches for your car at the drag strip. I've been drag racing for a while now, since 2003. Some stick shift cars along the way included Contour SVT, if you know what that is. Good for you. Most people don't. It was a neat little car that Ford made, a SVT version of the Contour with a sporty little six-cylinder motor that liked to rev in it. So I used to stick shift race one of those. I had a 96 Camaro Z28 convertible with the 6-speed manual in it, and I stick shift race my 2011 Camaro SS now. And there's not a lot of good video out there about how to stick shift race and how to launch specifically your stick shift car. And there's a ton of different ways to do it. I definitely don't have all of the answers, but I'm going to share with you what's working for me. This video is more for the 5th gen Camaro guys, the 2010 to 2015 Camaro SS and the ZL1 guys. But I mean, you can apply these concepts to any stick car. The same ideas apply. I kind of learned these things from a couple different guys that you can watch on YouTube. I know all of you have heard about Cletus. He uses the preload technique, but I first saw it from a guy named Billy Sharp. And he probably had the fastest, or one of the fastest stick shift cam only Camaro passes that I've ever seen. And he was kind of an inspiration to me to work on my stick shift drag racing game. So I hope this is helpful. I'm going to assume you know the basics of drag racing, kind of what to do at the track, how to stage the car and the beams, all that stuff. Let's talk a little bit about tires and tire pressure. If you're on a street tire, what I mean by a street tire is like a treaded, normal, drive it, all season or whatever, high performance, non-drag radial tire. Usually 22 to 25 pounds of air is about as low as you can go, and as low as you need to go to get optimum performance out of one of those. Those tires don't like big burnouts. If you're seeing smoke when you're doing a burnout with a street tire, you're doing a burnout too long. You're just getting it greasy. It's not going to stick any better when it's that hot. You just want to get it clean. So, into the water, clean it up a little bit, and you're good. A drag radial likes heat. I usually start with mine at 20 or even 18 if I know what the track's like, and I kind of work my way down to, probably usually 18 or 17 pounds. I like to do second gear burnout, so I don't have to rev the guts out of the motor to get the wheel speed I need to put good heat in the tire. Usually 3 to 5 seconds is the way I do it. And what I like to do, when I enter the water box, I'll be in first gear and I'll just give the car a brap as I let off on the clutch. And I'm not trying to do my burnout yet. I'm just trying to spin the tire over once or twice as I go through the water, and I'm trying to roll either to the edge of the water box or right out of it. And I want the tire wet but out of the water box, and I do that so that I'm not throwing water up into my wheel wells once I start my burnout. Like I said, I do a second gear burnout, so when I'm ready to actually do the burnout, I'm watching for the guy in the water box to tell me it's time to do it. A good guy in the water box, my guy at my local track, will actually tell me as I'm pulling through the water, so I can do that little brap and get the tires wet, and then he'll tell me when I can do my burnout. You may not get that kind of level of cooperation at your local track, so you'll have to figure it out. But you roll through the water, get them wet. Second gear burnout, like I said, drag radials 3 to 5 seconds. I'm just looking for a little bit of smoke. And you don't have to be violent to get these things spinning the tires. If you have a drag radial that's nice and wet, it's going to spin immediately, even in second gear. So I make kind of just like I would be making an aggressive launch, and then get down on the throttle hard as I pull my left foot over to the brake pedal and hold the car with that. If you got a line lock, that makes it even easier, but you certainly don't need a line lock to do a good burnout in a stick shift car. So I do my burnout. When I'm done with my burnout, I let off the brake before I let off the gas. I want the car to start rolling forward. Again, to get away from any little bit of puddle or anything that might have been under that tire while it was doing the burnout. Make sure it's nice and clean, then I step on the clutch as I let off the gas. Roll up into the staging. What I do is I drive the car up into the pre-stage beam and I stop with the regular brake pedal, and then I grab the emergency brake and I put firm pressure on the emergency brake, and then I start lifting off my clutch pedal until I feel the clutch just starting to engage, and it just drags the motor down just a little bit. You can hear the idle change just the tiniest bit. You're not looking to put much preload on this car at all, but what you want it just a little bit so that it's taking the slack out of everything. And this is really important for a couple of reasons. It's going to help. It's going to help you be ready to release that clutch, to be right on the edge of the friction zone. That's really, really nice for trying to get a good reaction time and trying to get a consistent launch. So that's important. But what's probably even more important, at least for your wallet, is that it will help reduce breakage. When you preload the driveline, you make it harder to shock the components. There's no slack to give things room to wind up and slam into one another, whether that's the ring and pinion, or the axles, the gears in the transmission, the drive shaft. All of those things have some give to them and some slop to them. They have lash. And if you take all the lash out of the system, you can't shock the driveline as hard. Imagine you're at a karate competition and you need to break one of those boards set up between two blocks. If you have zero lash with your hand pressed against the board when you start, it will be difficult or even impossible to break things. But if you were to draw your hand back and introduce lash in the system and then smash your hand down into the board, you can snap it easily. We're not going for an aggressive, clutch dump anyways. These Camaros don't really tolerate that long term. You'll end up with broken parts. But we're going for, an aggressive release on the clutch. So we get that little bit of preload on. When we're ready to move into stage, we don't move our clutch foot at this point. We've got the car just barely pulling against the clutch a little bit. Just ease the pressure down on that e-brake till the car just starts to creep as soon as it lights that stage bulb. Pressure back on the e-brake nice and firm. And then go to your launch RPM. If you got a two-step, that's really easy. You just smash this thing to the floor. If you're just using the throttle to find an RPM where the car is good, it's a little more work, but it's the same idea. Just get that thing revved up and ready to go. And then when you launch, the idea is that you start your clutch release, you smash the throttle, start your release, and drop the e-brake, kind of all in one fluid motion. It sounds like a lot to coordinate, but it's really not. Once you do it a couple of times, it's really, really natural. It's easy to drop that emergency brake. Just keep your thumb pressed on the detent all the time, obviously. Keep your thumb down on that thing until you put it all the way down. If you obviously pull the thing on and have to push the button to get it off, you're gonna have a bad time. So you're aiming for a quick smash of the throttle, but then a deliberate release on the clutch. And what I mean by deliberate is you're not just trying to dump that thing. Again, these cars really don't respond to that dramatic shock load very well, and they don't launch that well either. They're big, heavy cars. They got pretty long gears. Even when you get more aggressive gears in them, they want more gear than you can buy for these cars, at least in normally aspirated configurations. So you're going to want to slip the clutch over the course of, a quarter second or a half second or a second. It really depends on the combination, but you're going to find the more you can slip the clutch, as much as the clutch will tolerate, the faster the car is going to leave the line. The better it's going to keep its nose up if you can keep the RPM singing, somewhere north of 4,000, 4,500. When you really start learning how to launch these things, shouldn't ever drop below 5,000. Don't aim for that on your first try. Just get a feel for this preload thing. You can try the preload on the street too. It doesn't have to be at the track. Same concept works there. You got less traction to work with, but you can get used to the feel of the preload and the emergency brake and kind of all those pieces working together.
You good? Pull him up, pull him up. All right.
as far as shifting, I try to be intentional on my shifts. I've done some data logging, see if no lift shifting saves you any time. It really doesn't. The throttle plate on these cars moves just as fast as your foot does. So as long as your foot and clutch foot timing and throttle foot timing are good, you're not going to save any time there with a no lift shift. I got a no lift box in my car and I don't use it because it doesn't gain me anything. You just want to make good quality gear changes. The 5th Gen Camaro, the early ones. The 1-2 shift is notoriously difficult and will lock you out if you try to rush it. So you're better off, taking an extra, tenth or two of a second to just make sure it's consistent. I like to throw the car in neutral once I go through the beams instead of leaving it vacuum loaded the whole way down. I just kick it in neutral and then let it idle, and I'm, watching for the other car on the return road, making sure nothing crazy is happening there. But I'll show some videos here at the end of kind of what the preload launch sounds like, looks like, so to give you an idea. And then I'll talk through real quick some weak links on the Camaro specifically. The biggest problem most guys have is with the clutch pedal not returning all the way up when they make the launch. And that's actually not a problem with the clutch. It's a problem with the hydraulic system. Usually the guys that are having that problem, the first question I ask is, how's the fluid look? And usually it'll be dirty or nasty. These cars are really best paired with a dedicated reservoir. They use the brake fluid reservoir in original equipment configuration. That kind of sucks. You can get aftermarket kits to get a dedicated reservoir for them. That'll help you with establishing a routine of keeping quality, clean fluid in there. I like Motul RFB 600 for my fluid. It's a nice quality fluid. It's got a high boiling point, so it'll tolerate a lot of heat. And you got to keep it clean. A few times a season I will flush my clutch system out because it'll get contaminated quickly, and once it's contaminated you'll start to have those problems where you get some heat in the system and the clutch pedal won't want to return all the way. You got to keep it well bled too. A remote speed bleeder on one of these cars is almost a must if you're going to race it regularly, because you're just going to need that for flushing fluid and making sure you've got any air in the system taken out of it. Another weak link is the slave cylinder, and specifically the throwout bearing support. It's made out of plastic, and it's just junk. I mean, you almost wonder if it's an engineered failure on these things. They have that constant pressure throwout bearing arrangement on the slave cylinder, and so any heat in the clutch is getting dissipated into the slave cylinder, and the first thing it goes into is this stupid plastic throwout bearing support. And over time, with hard launches, the clutch getting hot, it will melt that thing, and eventually it'll cause, usually it ruins the throwout bearing. It doesn't just fail on its own, but it trashes the slave with it. What'll usually happen is when it fails completely, the slave will over travel, and then it will spill out all the hydraulic fluid into the bell housing, and you'll not be able to disengage the clutch, and it'll be a mess. Usually you get some squealing of the throwout bearing before it fails completely. It'll usually start to get out of alignment, and it'll make all kinds of nasty noises. Usually those noises go away when you step on the clutch a little bit, so if you got a car that squeals when your foot's off the pedal and then you just tiny touch the pedal a little bit and it stops, you're probably getting pretty close to having a slave cylinder throwout bearing problem anyways. I find that you need to cool the stock clutch between passes, or you will have trouble with it having enough capability to stay clamped up, and you'll have these heat issues I'm talking about. The stock clutch in my car held up really good. It had 40K for miles on it when we pulled it out. It had 2 or 3 seasons of drag racing on it. Some of those were bolt-on power levels, and then I had a year and a half of 500 wheel horsepower on sticky tires, launching it 5 to 6,500 RPM. And it took it very well. There was still some friction material left on it. It wasn't completely whooped, but it was time to do it. But keeping it cool is the key to making sure it works every pass. So I usually cool the car for 30 to 45 minutes between passes. You can pull that return spring out that the factory system has in it for a better feel. It's really a dual spring. It's an assist and a return spring. It helps bring the pedal up, obviously, when you release the pedal, but it also helps you hold the pedal down when you have the clutch pressed down all the way. That's why that clutch pedals in these cars have such a weird kind of feeling to it, where they're hard to push and then they get easy all of a sudden, and then when you're releasing the clutch pedal, that's where the problem is. All of a sudden it really pushes up quickly, and it's just a weird feeling, and you can just get rid of that spring completely. If you look up under the dash, it's pretty easy to figure out how to pull that thing up out of there. You can run a linear return spring if you like to, just to make sure you're getting a good clutch return. It's not really necessary. I used to run one, and honestly I've given up on that too. It's just no longer required. And then the other thing you want to think about is good clean transmission fluid will help these transmissions shift better. Redline D4 ATF is the one I like to go with. Yes, they take ATF. That's what the factory specifies. As far as upgrades, the slave cylinder, you can get a billet throwout bearing support to remove that problem with the plastic piece failing. Factory slave is still kind of not a great unit, and there's some aftermarket units like the Tilton 6107 that's a lot nicer to have. As far as other upgrades, subframe and differential bushings are the first place I would start when thinking about rear suspension. Those are the softest and the most likely to create wheel hop components. Kind of overlooked talking about wheel hop a little bit when you're launching, but I should have. You just want to get under the throttle. If the car starts to hop, don't try to drive through it. Usually gets worse, not better. And that's what breaks stuff, because again, you're introducing lots of shock loads, like over and over. Imagine dumping the clutch like 10 times in a row, really short succession. That's what wheel hop's doing to you. And it will break stuff. These cars will break axles, they'll break ring and pinions really easy. I've seen guys tear up drive shafts, all sorts of stuff. So don't drive through the wheel hop, just lift. And if you want to try to get rid of the wheel hop, you can upgrade the subframe bushings and the differential bushings to either poly bushings in the differential usually is the way to go, and you can either do a poly or even a solid aluminum subframe bushing. That's where most of the movement in the rear end is those bushings. They make aftermarket control arms, trailing arms, and tow rods for these cars as well. Those are all good upgrades. There is deflection that happens there as well, but those are all kind of wasted until you've done the subframe bushing, because the subframe moves around so much in these cars from the factory. There's a video from FOD on Facebook. It's old, or it's on YouTube. It's an old video. If you look around for it though, just look for like Camaro subframe bushings. You'll find they put a camera under the car, and when you see how much these things move in factory configuration, it'll blow your mind. Tire size is something you can play around with. These cars just don't have enough gear ratio. For a stick shift car with without any kind of power adder, you're going to want to run a 410. Even with a power adder, a 410 gear is usually the way to go on one of these, unless it's really, really fast. 410 is like 140 miles an hour at 7,000 RPM on a 28-inch tire, which is like more than fast enough for even like a mild amount of boost or nitrous. So they're the way to go. The lower gear makes the car easier to launch. You won't need as much clutch slip to get the thing to come up out of the hole and get into the power band. But with an all-motor car, you can actually play with the tire size to try to get some more gear ratio. A 26-inch tire on the back of these cars looks really funny, but that extra bit of gear ratio will help the car, especially down the back half of the track. It'll get the RPMs back up through the traps to where the car's actually making some decent power, and it'll add mile an hour to your trap speed for sure. These cars have a clutch style limited slip differential in them, and those things wear out over time. As the clutches wear, they just get weaker and weaker until eventually they do one wheel burnouts. And obviously, if the car will just do a one wheel burnout in the water box when it's got real traction, it's really not going to do you any good. So an Eaton True Track is a good upgrade for these cars. It's a stronger center section for the differential. I've not heard of anyone breaking them, although I'm sure it's possible. But guys break the stock Spider gears all the time, so by comparison, it's a much stronger unit. And it doesn't wear out. They're a helical design, so they've got a worm gear and a worm wheel, and they hold up really well, and they have a really strong bias ratio. So what that translates to is a really good traction. So definitely, if you're going to do gears, strongly consider doing a True Track while you've got it apart. Do it once, do it right. There's a few different companies, LPW and PCE, make a differential cover for this 218 millimeter differential in the 5th Gen Camaro. It's an aluminum case and cover from the factory, and they're really soft and they flex around. And when the ring gear starts walking away from the pinion under hard acceleration, that's where everything really goes bad for the ring and pinion on these, and you end up knocking teeth off of them. An aftermarket cover will help give some strength to the case and help it keep its shape under heavy load. And they also have load bolts, which is a set of bolts that go through the rear of the cover, and they clamp down on top of the ring gear caps, and that helps those caps hold the ring gear in place, which is, again, once the pinion is really driving against the ring gear hard, that lash space tends to open up between the gears, and once that opens up and it has a little room to work, it'll tear the teeth off the gear in a hurry. That's the usual failure mode for one of these differentials, is broken ring gear teeth. Other things you can think about is a shift light. The stock tack lags behind, especially like trying to make the 1-2 shift. You have to anticipate it quite a bit. If you're targeting 7,000 RPM, you probably got to try to aim for like 6,400 RPM on the factory tack, because it's so far behind. And even in the upper gears, it's just not good. And it's not good to have your eyes off the track. A shift light, especially one that you can program by gear to different RPMs, again, so you can put some anticipation in your 1-2 shift, is a nice way to just improve your ability to go down the track, make your shifts exactly when you want to, without having to try to look down at the tachometer. Data logging is a really nice tool to have if it's available to you. You can learn a lot about what you're actually doing with the clutch. These cars are equipped with a clutch sensor rather than a clutch switch, so you can look at your clutch data and you can see how you're moving the pedal, give you an idea what you're doing for your clutch slip. You can get a good idea what your shifts look like, and where you can clean stuff up, as well as how the car's running if you want to make a fueling change or anything like that. And then video. If you can get a friend to take some video outside of the car from you, that can be huge to kind of see what the car is doing on the launch. Maybe you're hitting the tire too aggressively and it's snapping it loose right from the hit, or maybe it snaps loose like a foot out because it's just loading the suspension up quick and then bottoms out and unloads the tire there. Just a lot of different things you can learn. You can listen to the way that you're making your clutch release. All of those things. Video is really valuable. If you can put one in the car too, that really helps. You can kind of treat that like game tape and rewatch your pass and kind of see what you did, what you liked, what you didn't like. And I encourage you to take pictures of your time slips. If you've ever picked up a time slip that's sat in your car for a year or two, you probably find you can't read it at all, because they just fade out. They use those laser printers, and you can't read them in a year or two after you've had them. But if you could put all your time slips, at least take pictures of them so you can categorize them and find them, track your progress. And I like to throw them in a spreadsheet. I know that's the nerd coming out in me a little bit, but you can really look at the data over a season and see what you were gaining on and where your changes were. Try to take good notes about what the air quality was like and just all the different things. Anyways, I hope that helps. This got way longer than I had intended on, but I think it's good information, especially for you Camaro guys. Gives you some things to think about as you go to the drag strip.